All right, so let's see some examples. So number one, we have y is less than or equal to -3, right? So in our mind, little thought bubble, we want to remember that this is the same as just y equals -3, right? In terms of where the boundary goes, and then we'll kind of go from there. So y equals -3, if that were the case, if this were an equal sign, then I would just start at -3 on the y-axis, right? And then I would just make a horizontal line. So y equals a constant as a horizontal line. So I know normally it would just be like this, right? Now let's take into account the inequality symbol. So it's less than or equal to. So if it's or equal to, it's going to be a solid line, right? So solid. So I'm going to make a solid line there. Okay, now I just need to know, am I going to shade above or below? So less than means below, right? So I'm going to shade below. And so I'm just going to, okay. All right. So that's how you graph inequality. So it's basically the same thing with sometimes you have a dashed line, sometimes you have a solid line, and then you just have to know that do you shade above or below. Okay. So now remember that this solution set, so instead of all just the values being on this line like it would be if it were an equation, it's the solution set is not only the line since it's solid, but it's everything below the line, right? All those points are a solution. Okay. So like this point right here is a solution, or this point is a solution, or this point, right? All these points that fall in that shaded region are solutions. All right, so number 2. So here we have x is greater than 2. So if I have x equals 2, x equals a constant, that's a vertical line, right? That would go through 2 on the x-axis. So it'd be something like this. Okay, but let's look at the inequality symbol and try to figure out what's happening. So since there's no or equal to, it's going to be a dashed line. So I'm going to make a dashed line. Dashed or dotted, right? Okay. And then since it's greater than, it's going to be, so usually we say above or below, but if it's a vertical line, it's a little tricky, but instead of above and below, it's left and right. So we'll go to the right if it's positive, or excuse me, if it's greater than, we'll go to the right. Okay. Let me put shade right. Okay. All right. So that's basically how you do inequalities. So let's take a look at number 3. So here we have actual y equals mx plus b format, right? So I'm going to start by plotting the y-intercept, which is 5, 1, 2, 3, 4, 5. Okay. Then I'm going to use the slope to find the next point. So this is -3, so I can think of that as -3 over 1, right? So I'm going to go down 3, 1, 2, 3, and over 1 to the right. So that's how I find the next point. Now, if normally if this were equation, we would just connect the dots, or draw a line through the dots and we'd be done. But now we want to think about, okay, is this going to be dashed or solid? So first of all, there's no or equal to, so it's going to be dashed. Okay, and then the last thing is the shading, right? So since it's less than, it's going to be shaded below. Okay, so the way I always think of it is I start from the line and I just go straight down, right? That's it's all that shading right there. All right, so that's what our answer is. Okay, so this one, the solution set is not on the line, right? So none of these are solutions. Okay, so anything on this line is not a solution, but everything in the shaded area is a solution. Any point in the shaded area is a solution. So you can always double check, like if I plug in 0, 0 for the origin, that should satisfy this, right? So like if I have 0 is less than -3 times 0 plus 5, then it just becomes 0 is less than 5, right? Because this all goes away. And that's true, right? So that's a way to check your solution in an inequality, is just to plug in a value that's in the shaded area and see if it makes the inequality true. And if it doesn't, then you can go back and check your work. All right, number 4. So here I have an equation that's not solved for y, right? So that's what I want to do, is solve for y. So I want to get y by itself first. And so what I'm going to do is I'm going to subtract x from both sides. And so what I'll get is negative 3y is less than negative x plus 6, right? So I put the negative x first, and then I put the plus 6 after. And those are not like terms, so I can't combine them. So next I'm going to divide by negative 3. So remember, when we multiply or divide by negative with the inequality, we want to flip-flop the sign, right? We want to turn that sign backwards. So it's going to be greater than or equal to, and then negative turns into a positive, so it's going to be x over 3. And I'm just going to make that 1/3 x, right? So 1x over 3. And then positive divided by negative is a negative. 6 divided by 3 is 2, so it'll be negative 2. All right, so now I'm going to start with plotting the y-intercept. So that negative 2 is going to go right here. And then the slope is 1/3, positive 1/3. So it's going to go up 1 over 1, 2, 3. Okay. Then I'm looking at the inequality symbol. It's or equal to, so it's going to be solid. So I'm going to draw a solid line through here. Okay. And then the last thing is the shading. So if it's greater than, it's going to be shaded above. So shaded above. So it'll be okay. All right. So hopefully that makes a lot of sense. Hopefully it's very similar to, or you kind of reminiscent of what we did with graphing linear functions, and hopefully you're great at that. And whether or not this is a review, hopefully it was pretty easy to pick up.